Hello everyone and welcome to yet another episode of Darko's Game Dev Cookbook. In today's video we'll be talking about the magic that happens behind the scenes in multiplayer games. To be more specific, we'll be talking about game state replication. Let's go! Don't worry, in this video I won't go into super complex details of how multiplayer games work. That's a huge subject and it's not something you can just tackle with a single few minutes long video. The thing I will talk about though is one aspect of their complexity, and that is the aspect of replicating the game state. When you think about replication as a word, it denotes the action of copying or reproducing something. But what does replication mean in game dev? Well, creating a network multiplayer game is much harder than producing a single player game, obviously. As soon as you have networked multiplayer, you're in the land of distributed systems, or you have multiple machines communicating with each other. And as soon as the systems are distributed, communication becomes something that is more difficult to execute than when you work with just a single machine. So all of a sudden there is this whole layer of communication that needs to happen between machines, and this communication needs to be precise and fast, so that the players don't even realize that it's happening in the background. And the whole point of multiplayer is making players feel like they're a part of this same world. For example, if one player opens a door, all players who are in the same world and are in range should see the door open. And this is where replication comes into play. Now, if you go back to the replicator example, or to make it simpler, let's use the 3D printer analogy. The way a 3D printer works is that it receives a blueprint, and then based on that, it's capable of producing a real 3D object. What your machine does is pretty much the same. So you have this thing called game state, and your machine is capable of processing this game state and displaying it on your screen. This sounds logical, right? And it makes sense. You have this game state. Game state could be anything, like player positions, for example, and you just display them. The goal of replication in multiplayer games is to ensure that the state of the game is consistent for all the players in the session. There are two main ways in which the game state can be replicated. You have active and passive replication. Active replication is somewhat of a legacy replication. It's a peer-to-peer replication model in which each player machine has this identical initial game state stored internally, and during the game each participating machine actively broadcasts and receives information from all other machines, and using this information sharing, all clients update their own copy of the game state. This is quite a fragile model. Why? Because if each machine starts the game, so you join a session, they have this game state, that game state is created. As you interact with the game, that game state is modified. But as you interact with the game, your interaction needs to be passed to all the other players in the session. So all of them need to know that you did something, move forward, for example. So you will send your input literally. I mean, it depends on the implementation, but let's say you send your input to all other clients. All those machines will calculate the same thing your machine did deterministically. So you should move in theory by the same amount of space. So you should move by the same distance. But it's really easy to get into a desync state, into a broken state where the machines don't have the same game state. So here's the thing. It might be that not all machines in the session perform some low-level calculations in the same way. And by that, I mostly refer to floating point numbers. If you don't know what floating point numbers are, I definitely suggest you Google. But in theory, different machines might handle these numbers differently. The accuracy in which they perceive these numbers might be different. They might be rounding these numbers in a different way, and that causes troubles. If you think about just making a tiny mistake in one frame, that is okay, but that mistake, since you have that internal game state that you're constantly updating with this move 1 millimeter, move 1 millimeter or similar, if that 1 millimeter is not really 1 millimeter, in 10 minutes of gameplay, you will literally be moved in meters less than you should be, for example. And that's the problem. So when that game state becomes broken, it's almost impossible to recover from it. This model is, for that reason, quite legacy, and it has been used a long time ago with the first multiplayer titles out there, and one of the most famous titles were Duke Nukem 3D and even Doom at that time. Nowadays, the main replication model used by online multiplayer games is called passive replication, which introduces this concept of a central authority called server. So instead of each client talking to other clients directly, they now communicate with a machine called a server, and that server then communicates with all other clients. So each client receives input from the player, and then that is dispatched to the server, and then the server dispatches that to all other clients. So if you press W to move forward or control your stick to move forward, your client will then perform calculations to move you forward, so the action feels instant on your game client, so you feel the punch when you move. However, at the same time, what happens is that your input is sent to the server will do the same calculation as your client did, and then what happens, it will dispatch that information to all other clients. So it will say you moved by a certain distance, but it will also tell you that you actually moved by a certain distance. And what can happen in case when you have some network hiccups, for example, you move, but that information doesn't really get to the server. So the server won't do those calculations, your client will. And you will move for 1 meter, and all of a sudden the server will be like, oh, you didn't really move anywhere. So what happens then is so-called correction. So the server will dispatch the information back to your client and say, hey, you're actually here, so you're gonna get that famous rubber banding or lag in general. So the server receives all the information from all the clients in the game, and your client gets the information it needs to display the game state on the screen from the whole server pretty much. And your client is constantly receiving this information that is crucial for you to be able to perceive the game state. Now you know what passive replication is, now you know what active replication is, you know how they kind of work. You also know when you connect to a server, it's obviously passive replication, so you know how this state propagates and where this game state is being handled. And that's pretty much it for today's video. If you liked it, please do hit that like button. If you like the content I'm creating in general, hit that subscribe button as well. That means a lot. And until the next time, enjoy!